Hello students, in the last video we have discussed about different types of systems. Today let us know state of a system. Already you know that there are three states of matter at normal conditions of temperature and pressure. According to thermodynamics, we are going to define the state of a system as where its measurable properties of the system remain constant. Here, the measurable properties are pressure, temperature, and volume. If the temperature is constant, if the pressure is constant, if the temperature is constant, if the volume is constant, or any other measurable property has a constant value, then we say it is its state. The values of measurable properties of the system when changes, the state of the system also change. For example, ice is the solid state of water. To mention solid state of water, the temperature must be below 0 degrees Celsius, under 1 atmospheric pressure. If the value of temperature changes, the state of water also changes. It turns to liquid. If its temperature increases more than 100 degrees Celsius or equal to 100 degrees Celsius, then the state of water changes to a gaseous state or vapor state. So here, according to thermodynamics, whenever the measurable properties have a constant value, under such constant values, whatever be the state of the system, that will be the state of a system. If these values changes, then we say there is change in the state of a system. Okay. After this, let us go for another one term, that is state functions. Here, any properties which define a state of a system or state of a matter are nothing but state function. We define state functions as the physical quantities whose change in value depend upon initial state and final state and independent of path by which the change is occurred. Example for this is pressure, volume, temperature, internal energy, etc. Here, the value of pressure or the value of volume, the value of temperature or internal energy, the change in its value only depends upon initial state of the system and final state of the system, and it is not dependent on path by which the change is occurred. In which way we are going to change the temperature, in which way we are going to change the pressure, or in which way we are going to change the volume, that is independent of the path. Only it depends on initial state and final state. For example, temperature is a state function. Why temperature is a state function? Because change in temperature only depends upon initial state and final state. For example, I have given 100 ml water for two students and ask them to raise its temperature from 25 degrees Celsius to 50 degrees Celsius. Here, the initial temperature and final temperature are important. How they are going to change that temperature, it is I am not interested, or I am not it is not required. Whether you are using by an electric stove, whether you are using Bunsen burner, whether you are using spirit lamp, I am not interested, but I am only interested its values, that is initial value and final value. So temperature is a state function. I think you understood about this. The state functions are also called as state variables. Why we call state variables? Because Whenever the state of the system changes, these values also changes. So we call them state variables. Next one is the path functions. Path functions means the change in its value depend upon the path by which the change occurred are called path function. For example, work, heat, etc. are the path functions. Work is a path function because work done by the system depends upon the path in which direction or in which way the work is going to be done. Heat is also a path function because amount of heat absorbed by a system depends upon in what way we are supplying heat energy. For example, I have given 1 liter water to two different students and ask them to heat for 5 minutes. One student heating it by using Bunsen burner, another student is using heating the water by using an electric stove. Here, the amount of heat absorbed by water in 5 minutes is different. So here, heat absorbed by the system depends upon the path by which we are doing that work. In what way we are doing that work, or in what way we are supplying heat energy to the system, it depends. So heat and work are called the path functions. After state functions and path functions, let us move to macroscopic properties. Already I told you what are macroscopic properties and what are microscopic properties. Macroscopic properties are the properties of the system which can be measured in bulk. If the system is in bulk, then we are going to measure its property, otherwise we cannot. Such type of properties are called macroscopic property. Some of the macroscopic properties are temperature, pressure, volume, density, melting point, boiling point, etc. Temperature is a macroscopic property. For example, if you ask to measure the temperature of water, whenever the water is in bulk, we can measure. If the water is in droplets form, or temperature of a drop of water cannot be measured, but the temperature of water when they are in bulk we can measure. So such type of properties are called macroscopic property. And already you know what are microscopic property. The properties which are related to micro level, that is atomic level or molecular level. Example for the microscopic properties are ionization energy of the atom, atomic radius, electronegativity, electronegativity, electron gain enthalpy, etc. So these are microscopic properties, but we are interested only in macroscopic properties. Okay. Macroscopic properties are further classified as extensive properties and intensive properties. Extensive properties, what are extensive properties and what are intensive properties? Let us know. Extensive properties means the properties of the system which depend upon the quantity of the matter present in the system. Its value depend upon quantity or amount of matter present in a system. For example, your college bag or your school bag. The mass of your school bag depends upon amount of matter, that is number of notebooks, number of textbook present in it. So mass of your school bag or college bag, it depends upon quantity of matter present. If you have only one book, then mass will be less. If you have many books, you have your the mass of your bag may be more. So the value of mass depends upon amount of matter present in the system. So such type of properties are called extensive properties. Example for extensive properties are mass, volume, heat capacity, internal energy, enthalpy, entropy, Gibbs free energy, etc. Mass, volume, heat capacity, amount of heat stored in a body, that also depends upon m, that is heat capacity is equals to m into s into delta t, that is mass of the body. It means heat capacity is directly proportional to mass, and mass depends upon quantity of matter. So here heat capacity is also extensive property. In the same way, you are going to learn in detail about internal energy, enthalpy, entropy, Gibbs free energy in your future classes. Let it be. Now, intensive properties. The properties of the system which is independent of the amount of matter present in the system. Whatever be the matter, whatever be the amount of the matter, the property remains the same. Such type of properties are called intensive properties. Example for intensive properties are temperature, pressure, refractive index, viscosity, density, etc. Just I clear what are intensive property. For example, temperature. Temperature, if we are interested to measure the temperature of water present in overhead tank, for that you are taking a little amount of water and measuring its temperature, and whatever you are getting that temperature, that will be the temperature of your water in overhead tank. It means the value of temperature is independent of amount. इसका मतलब अगर आप ज़्यादा लेंगे टेम्परेचर ज़्यादा आएगा, या अगर अमाउंट कम लेंगे अगर टेम्परेचर कम आएगा, ऐसे कोई नहीं है. Here temperature only depends upon independent on amount of matter present in the system. So temperature is an intensive property. In the same way, pressure, refractive index, freezing point, specific heat, etc. are intensive properties because they are independent of amount present in the matter. I think you understood this extensive properties and intensive properties. Let us learn little in detail about the extensive properties and intensive property. An extensive property may become an intensive property by specifying unit amount of a substance. It means an extensive property can be converted into intensive property whenever that property is specified for a certain amount of substance. For example, mass is an extensive property. Whenever we confine mass of a unit volume, that is mass per unit volume, nothing but density. So here density is an intensive property. It means an extensive property can be converted into intensive property whenever we specify that property to a certain amount or fixed amount of substance. Okay, that is density equals to mass by unit volume. Here mass is an extensive, unit volume, whenever we confine to unit volume, it becomes density, where density is an intensive property. Okay, second one. The ratio of two extensive properties is always an intensive property. whenever we take the ratio of two extensive properties, the resultant is an intensive property. For example, mole fraction. Mole fraction is an intensive property, and this mole fraction is the ratio between number of moles of the component to the total number of moles of the mixture. Here, number of moles of the component is an extensive property because it depends upon the amount. Total number of moles, it is also an extensive property because it is also depends upon the number of amount of matter. So the ratio of the ratio of two different extensive properties become an intensive property. And the third one, extensive properties are additive but intensive properties are not. It means extensive properties can be added. For example, mass can be added, volume can be added. 10 gram sugar, 10 gram salt, whenever we mix, the resultant is 20 gram. 100 ml 1% sugar solution, 100 ml 1% sugar solution, whenever we mix, the volume of sugar solution becomes 200 ml. So here volume is an extensive property and we can add. But intensive properties we cannot add. Here 1% solution, that is concentration. That is 100 ml 1% solution, 100 ml 1% solution. Whenever we mix, the volume of solution become 200 ml, but the concentration become 1% only. So here intensive properties cannot be added, whereas extensive properties can be added. So by this I am going to conclude today's class, today's video. I will continue in the next video. Thank you.